Hey, this is Mr. Weisenfeld. We're talking about PS2A. That's the structure of the atom. Subatomic particles, particles that make up the atom. Part of what we're looking at here is this review sheet that we did for that, where I ask you to fill in the blanks. This was, I think, on purple paper. And I get a lot of questions about this, and so I wanted to put it here in a video so we can get it right. So let's get started. You know, you can read this stuff up here and give me some feedback if it's clear or not, but let me walk through how to use it, because this information should be enough to help you answer all these blanks down here. So let's get started. First of all, a nuclide symbol, that's what we call this, nuclide, N-U-C-L-I-D-E symbol. It's got the atomic symbol, AU. This is a sample, right? It's got the atomic number down here, lower left, which is also the number of protons. It's got the mass number up here in the upper left. And it's got the ion charge over here in the upper right. So, given protons, neutrons, and electrons, you can put all that information around a symbol here. Or, given a symbol, you can give me these numbers here, and you can tell me about whether this atom is an ion, so if it has a charge, and if it has a positive charge, it's a cation, and if it has a negative charge, it's an anion, and if it's neutral, which means it has no charge. We're also going to go over this common isotope thing. Been very confusing for people, and I apologize for that, but let's try and make it a little clearer. So here we go. Let's get started. Take out your sheet or follow along. First of all, number of protons. This will determine what element I'm talking about. There's only one element with 34 protons on the whole periodic table, and that one is selenium, Se. But let's review here. If I've got the periodic table in front of me, I'm looking for the one that has 34. So, you know, the numbers go up, but as I'm looking here, I find the one that has 34 right here. This is the atomic number. Let's review what's on these each of these squares in the periodic table. You've got the atomic number here. Please do not confuse that with the atomic weight or the atomic mass, as I like to call it. Atomic mass is right there. Not the same. Sometimes pretty similar. Not the same. Repeat after me. Atomic number, not the same as atomic mass. Okay, then there's the chemical symbol, and then there's the chemical name, or sometimes called the atomic symbol or atomic name. Anyway, we were back here on selenium, 34 protons. That number also goes down here, 34, number of protons. And we are good. We've got the atomic symbol, and we've got the atomic number, or number of protons. Cool? Alright, this number up here, the number up here is called the mass number. It's equal to number of protons plus the number of neutrons. So you can look right here, this is the number of protons, this is the number of neutrons. So let's just do this. 34 plus 45 equals the mass number. I'm going to write it here once, and then we can go back to it when we get confused. So, number of protons plus the number of neutrons equals the mass number. 34 plus 45, 79. You can write that number right up here. Mass number. Okay, now, what's the charge on this atom? You know, there might be a charge, there might not be a charge. It all depends on how the number of protons compares to the number of electrons. So you look at this number 34, that's the number of protons. What's the charge on a proton? Positive. Good. What's the charge on an electron? Negative. Good. So if this atom has more protons than electrons, it has an overall positive charge. So I can jump over here and say it's a cation. It's got positive charge because it's positive charge. Let's just put a positive down here just to remind me how I got there. And furthermore, the number of protons in excess of the number of electrons is the ion charge. So this is a 2 plus. How did I get that? I can take protons and subtract electrons. If you take protons and subtract electrons, you can get the ion charge. All right. Now, is this a common isotope? You know what I like to do? I like to write over here what the atomic mass is for this element. In future versions of this little worksheet, I'll put this column over here so you can fill it out. Keep track of it. Anyway, back to the periodic table. Here's selenium. It's the atomic number of protons. Here's the atomic mass, 78.96. Let's write that down over here on our 78.96. Now we've been told that this number, it's different because of isotopes. That means there are atoms of selenium out there in the world that have a different number of neutrons. Not 45, maybe 44, maybe 46, but they're all natural. You know, they were made a long time ago. The point is, you go out to your backyard, you grab a bucket of selenium, they're going to be made of atoms. There's going to be a lot of atoms in a bucket. If you could look at each one of those atoms, not every atom has 45 neutrons. But yet you'd like to know what the average mass is for all those. So that's what's in the periodic table. So you look this up in the periodic table, the atomic mass, you look it up, 78.96, you round it to 79, and if that 79, the atomic mass, is the same as the mass number over here, this is the mass number, then it's called a common isotope. So common. Alright, you're done. You filled in all the blanks and you move on to the next one. So SC is our element for the next one here, number 2. SC is on the periodic table here somewhere, so you just got to take a look. Sometimes it helps to look a little closely at it. There we go, scandium. It's number 21 on the periodic table. And 44.96. So let's write those numbers in. So atomic mass, 44.96. But more importantly, atomic number, 21. So you write that here, that's the number of protons, 21. Write that here, that's also the atomic number. Atomic number equals number of protons. Then, what's the mass number? Mass number is number of protons plus number of neutrons. 21 plus 9, 30. Write that number up here. Then you take a look at if this is cation or anion. 21 minus 15, protons minus electrons, 6 plus. So that's good news. And check this out. If the atomic mass is 44.96, so about 45, then this number is not the same as this number here. So this is an isotope of scandium, the mass of which is not close to what the mass of scandium should be, in the real world. So this is not common. You can write common, you can write not common, you can write no. We're good. Alright, next one. Moving on. Please follow along. Take notes. Ask questions next time you see me. What do we got? We've got this right here is the atomic number, also the same as the number of protons, always going to be that way. 54, looking at the periodic table, looking for 54. There we go, xenon, 131.3 is the atomic mass. Let's write those numbers down. Let's take note of those. So 54 xenon Xe, and atomic mass again was 131.3. Alright, but you know what here? I've got the mass number here, and I know that equals 54 plus something. I know that my mass number equals protons plus neutrons. So what plus 54 equals 55? Well, 1. 1 neutron in this whole atom. And so we're done with that one. This is another cation. We expect the number of protons to be more than the number of electrons. So 54 minus 52, protons minus electrons, let me put a little squiggly circle around electrons, equals 2 plus. Alright. And this is a not common isotope because the atomic mass of, in general, xenon that you found in your backyard is not the same as this crazy xenon that Mr. Weisenfeld dreamed up on this worksheet. So this is not the common isotope. No harm done, no foul, just like, sorry, that wasn't what you can find commonplace. Alright, gallium. Number of protons is the atomic number, 31. This number right here, 31. Number of neutrons, ladies and gentlemen, 35 equals 31 plus something. What is that something? Well, you can take 35 minus 31, you get 4. We've got 4 neutrons for gallium. Ooh, good question. I hear you saying, what is neutral mean, Mr. Weisenfeld? Neutral means that this atom has no charge on it. I mean, this atom has same number of protons as electrons. Protons positive, electrons negative. Same number means a neutral atom. So you can write this right here, 31 electrons, neutral. We've got to go to the periodic table real quick. Gallium, 31. Atomic mass, 69.72. 69.72. It's not common. This is not the common isotope. This is an isotope purely developed for some kind of worksheet, for some kind of teacher, in some kind of classroom. Alright. Here we go. Next one. Number 40. Element number 40. Let's check our table. 40. That number, 40, zirconium, is atomic number of protons. Let's also write this over here, 91.22. I just happened to notice that's atomic mass. 40, zirconium. And we know that 40 plus 51, so protons plus neutrons equals mass number. You know, Mr. Weisenfeld, what are you talking about? What's the mass number? Well, when you look at an atom, it's got electrons flying around, and then in the center here, it's got protons and neutrons. The mass number just says, count up the stuff here in the nucleus. It's the stuff that weighs the most. This stuff in here is the most weight. You can have like 1,000 electrons, and 1,000 electrons will only weigh about as much as a proton. But you know, we don't have any elements with 1,000 electrons on them, so we ignore electrons. Anyway, the mass number just says, count up what's in the nucleus. 40 plus 51, 91. In fact, another word for these, you don't need to know this, you can ignore this for a little while. Nucleons. Everything in the nucleus is called a nucleon. Nucleon. Alright. What's the charge? 40 protons, 38 electrons. Ooh, I've got more protons than electrons. I got a cation, I'm telling you right now. But how many more protons and electrons? 40 minus 38. So 2, 2 plus 40 minus 38, 2 plus. Okay, we're good? Moving on. Common isotope. Hey, common isotope because 91 is about the same as 91. So atomic mass about the same as mass number. All right, here we go. Next one. He, helium. Ooh, I know helium. Helium has 2 protons. So that means its atomic number is 2. 2 plus 2 is 4. We're good for the mass number. Ooh, 5 electrons. Interesting. This should be an anion because the number of electrons is more than the number of protons. But by how much, mister? Well, by about 3. 3 minus. So 2 minus 5. 2 minus 5 equals minus 3. The charge on this atom, which is now an ion because it's got a charge. Is this the common isotope? Well, helium's atomic weight is, I know it's over here, upper right. So scroll over here with me to the upper right, 4.003. Let's go back here. So the atomic mass, 4.003. Well, that's pretty close to 4. So this is the common isotope. This is exactly what you find in any party balloons or anything that you'd buy. It would probably have an atomic mass of 4. Here we go. We're almost done. Number 7. 15. 15. What's this number mean again? Protons. Oh, yeah. It's the atomic number. Good. 15. Phosphorus. Atomic mass, 30.97. Let's write that down over here. 30.97. 15. 15 plus something equals the mass number. So protons plus neutrons equals the mass number. This is 16 here because 15 plus 16 is 31. Then, it's got a 2 minus. You know what though? We haven't had a lot of these examples where I have these 2 numbers and I have to tell you the electrons. So let's see here. 2 minus means I'm an anion. I got more electrons than I have protons. So write anion over here because it's a negative atom. So if I've got 2 more electrons than protons, I must have 2 more than 15. I must have 17 electrons. But mister, look at, you did that too fast. You gotta slow down for me. I can't do that. Alright, so try this. 15 minus a minus 2 equals what? Equals plus a positive. So that equals 17. So, when you're asked for this number here, number of electrons, do this. Do protons minus the ion charge. And I'm looking ahead. We're going to be able to do this right here on number 9. So don't move ahead. Stay with me. Next one, nickel. Nickel is atomic number 28. But you know what? That's also the number of protons. So 28 goes here. And 28 plus the number of neutrons is the mass number, 37. So that's how much stuff you've got in the nucleus of this atom. It's not common. Oh, by the way, did I say that the one above was common? Because this from the periodic table was equal to this. We're very close. All right. We've got 2 plus here, which means this is a cation. It's a positive ion. It means it has more protons than electrons. How many? Well, 2. Here's protons, here's electrons, so 2. And we're done on that one. You could double check that this is not the common isotope. Let's do that real quick. So nickel, right here. Nickel's 28. Nickel here, 28 protons, atomic mass of 58.69, 59. This 58.67 was it? 58.69. 58.69, that rounds to about 59. It's not the common isotope because 37, so we're good. All right, anyway, last one. What element has number 5 because I know this number is the atomic mass. Sorry, atomic number, which is this number, protons. What's number 5 again? Boron. Boron has an atomic mass of 10.81. Let's write that down over here. Boron, 10.81. 5 plus something equals 9. Remember. Or, look at here, I have a little hint at the bottom of this page sometimes. Mass number minus protons. So 9 minus 5 is 4. Protons plus neutrons equals mass number. Protons minus charge, here's a little hint down here. We did that right here. Protons minus the ion charge. So 5 minus a minus 1 equals 6. 6 electrons means I have one more electron than proton. It means I have a negative charge. Means I have an anion. Is this the common isotope or not? Well, I know the atomic mass is 10.81, which is 11 almost, which is nowhere near 9. Not common. And Mr. Weisenfeld forgot to write the boron symbol. So boron's atomic symbol is B. Okay, folks, there you go. This is the stuff you need to do to be proficient on the assessment for PS2A. And if you do this worksheet, it might have any number of these atoms, anything from the periodic table, any elements, so you need to be able to do this in a general way. You need to know how to find the atomic mass and the number of protons for an element. Okay? Thanks for listening.